James, thank you for inviting us here today to talk about Promethean. So tell us, what does the company do?
Promethean was a spin-out from the University of Nottingham back in 2007, based on the work of Professor Ed Lester. Our history was all around the continuous production of various nanomaterials, and certainly back then it was about metals, metal oxides, and a variety of different materials. In 2021, we made a strategic pivot to focus on a really exciting class of materials called metal organic frameworks, or MOFs, as we'll talk to them about. And they've got some incredible properties. And a combination of unsolicited customer demand as well as our real unique ability to make these materials at scale really allowed us to focus on those materials.
One of the most interesting aspects of MOFs is their versatility. So would you tell us a little bit about all of the different applications and sectors that they have applications in?
MOFs have been around for about 40 years now, and there's over 100,000 different structures that have been reported in the literature. Probably the most prominent one right now is around carbon capture and the use of that both for point source carbon capture as well as some activity looking at them for direct air capture where there's lower concentrations of carbon dioxide in the air. There's a huge amount of potential in what MOFs can do. At Promethean, we're really focused at this point on carbon capture.
So this is Promethean's prototype carbon capture demonstrator unit. It really is at a scale that's between the instrument that we've seen in the lab and the demonstrator unit or the pilot unit that we've recently installed at Drax's Selby incubation site. So in my hand here, I've got a sample of one of Promethean's leading carbon capture MOFs. On our demonstrator unit, we've got 3 columns, and those are currently filled with a variety of forms of our carbon capture MOFs. And the unit itself allows us to examine the performance of the different forms of our MOFs in a simulated carbon capture environment. Currently, we've got it set up to examine CO2 uptake performance, and we've got a gas coming into the system that's about 13% CO2, which is somewhat representative of a post-combustion flue gas stream. So we'll flow that gas in with that CO2 concentration. When we want to, we'll divert that gas into one of our MOF columns, and we'll be examining the CO2 concentration at the outlet of the MOF column. So we've got our gas mixture coming in, that's currently at about 14-15% CO2, and we've now diverted the gas flow through one of our MOF columns. And as I mentioned earlier, we're looking at the CO2 concentration at the outlet of that MOF column now. So that's rapidly dropped down to a roughly 0%. In fact, right now it's about the concentration of CO2 in air. So we've dropped from 15% down to about 0.04%. And that CO2 that's missing, so to speak, has been captured within our MOFs, within our columns.
So one of the things that stood out for us about Promethean is the very clear USP. What would you say Promethean USP is?
The biggest difference about what we do is that we're able to manufacture MOFs continuously. Our technology allows us to take MOFs and produce it at significantly larger scale than what's been done before. So we're currently at the multi-ton scale, whereas most of the MOF community still talks in grams, maybe even kilograms. So that's something that we're very proud of, obviously. But having that scale also is one of the elements that allows us to drive down to a lower cost. But in these materials and the applications that we're pursuing, it's also really critical that we don't lose some of those important quality parameters of the MOFs. So, we can't just pursue cost and scale improvements if we don't make a MOF that can do the job that our customers need us to do. So it's those 3 elements combined is really what our technology achieves.
Could you tell us a bit about what this latest funding round with us and Aramco as the lead investors, what will that enable the company to do in the next few years?
We certainly have got to continue to advance the technology, and we have to convince our customers that this new technology is something that they don't need to take an exorbitant risk on. So we have to do more demonstrators. We have to continue to show that we can take the MOFs from the history that we've had in the reactor technology all the way through to a form that our customers want it in, whether that's a powder or a shaped material, whatever that may be. So certainly that's on the technical side. On the market side, we have to show customers that the materials work well in their applications. So that means doing real-life demonstrators of ever-increasing scale and complexity. Promethean has got this facility here, which we're very proud of as some of the background of the university spin-out nature that we have, but it's not set up to be a large-scale chemical manufacturing site. So a big part of the use of funds is for us to assess and ultimately move into a new facility and basically take some of the advancements that we've made in some of the reactor designs and take them with us and increase our scale and capacity. And then lastly, as we grow, clearly we have to expand the skills and the number of the team that we have.
For me, Promethean from the onset was a very interesting investment opportunity. One of the main reasons is that I'm personally passionate about climate, but also with my chemistry background, being able to marry the two and get to review such an interesting business as Promethean was a joy, really. I had been researching the carbon capture sector for a while. I had been working on an investment thesis, talking to numerous players in the ecosystem, and we were looking for a company that met the Mercia Ventures investment criteria. And one of the things that stood out for us, as mentioned earlier, was the management team. And the fact that you were leading the management team with your years of experience in the corporate sector, in the chemical sector. Another one was the uniqueness of the technology. So seeing that this is a technology that's going to literally unlock markets. After doing a bit of research on MOVs, we saw that the key bottlenecks to MOVs deployment in industry were the challenges of price and scalability. And seeing that your technology was able to unlock that and that you already had commercial traction with customers in several sectors, that was great validation for us that this was a technology with huge potential ahead. MOVs is still a nascent market because of those challenges that I just mentioned, but it was after doing commercial DD and on our own research, it was clear that they have potential to unlock very large markets.
We are unlocking markets that don't really exist today. I mean, even in the carbon capture space, there is technology that exists today, as you know, for carbon capture, and particularly sort of the amine processing type materials. But when you think about the amine materials, for example, they have some significant challenges. They have a very high energy burden when it comes to regenerating the amine and getting it to release the CO2. They're not always the nicest of materials to handle, both at the beginning of their life and certainly once they've degraded. And a lot of the amine plants have a large footprint requirement. We fundamentally believe that MOFs help address many of those challenges and will help to unlock a more energy efficient and actually sustainable decarbonization sector, particularly when it comes to carbon capture. As we've learned more about the space, we still think there's a great prize around infrastructure scale carbon capture. In the interim, though, what we have to do is establish a go-to-market strategy that allows us to work on related technologies that will help start to generate some cash in the shorter term, but it has to be aligned. We don't want to do any revenue for any profit anywhere if it's going to take us in the wrong direction of the strategy that we've laid out. And that's where we think both water harvesting and biogas upgrading from anaerobic digestion help us go down that path, because they're very aligned in terms of the end goal. They'll help establish technical de-risking. And obviously then, we think it's a lower barrier to entry for the customers to take a risk on a newer technology. So we're very excited about the path that we've built and, look forward to fleshing that out in the months ahead.
So when you think about the future, where do you see the company going? What's your ambition in the long term for Promethean?
Yeah, I mean, it's going to be a combination of scale up and scale out. I mean, the technology that we're developing has been chosen specifically that gives us that amount of flexibility. Even if this plant could do its full 1,000 tons a year, we've got new reactor designs that can take that up to 5,000 or even 10,000 tons a year without even having to change the footprint of the reactor itself. It will certainly need bigger tanks and bigger processing equipment to go with that. We will need to expand internationally. That's going to come with an incredible set of challenges of setting up legal entities, operating in other countries, things that I've obviously done in my career, but not being solely responsible for, of taking it from something of Promethean scale today. So, I mean, that's all really exciting. It's why, a job as CEO at a company like Promethean was so attractive is the chance to be able to do that. And they don't come along very often in a career.